In this video, I'm going to go over a lot of definitions, some basic ones that I think you guys will pick up pretty quickly, and I know you know at least a couple of these. Then we'll look at doing some questions with those, some basic ones, kind of like the very first thing we ever did with points, lines, and planes. This is just about circles. And then we'll look at two theorems, which we'll then use to do a few problems together. Okay? All right, so the first thing on this page is you'll see that circle up there. And we have all of this vocab. I'm not going to read through them. You'll have a chance to kind of go through them all. I'm hoping you guys remember the radius, right? The segment whose endpoints are the center of the circle and any point on the circle. The diameter, which is a chord that contains the center of the circle, so it's got to go through the center. A chord, as you see in the figure, does not actually have to go through the center, just the endpoints have to be on the circle. Then we have ones that you may not actually know. These might be new ones to you. We have a secant, which is just a line that intersects a circle in 2 points, and then a tangent, which is a line that's in the plane of a circle that intersects the circle in exactly 1 point. Notice if you look at the figure where that tangent is intersecting at that point of tangency, you'll notice that we do have a right angle symbol, which is going to come into play later on. Okay, so let's kind of do some of these. This will go pretty quickly for this first page. So name two chords. All right, so I see chord RS is a chord, that segment, as well as YT. Right, those are segments that have endpoints on the circle. 3 radii, okay, so they have to include the center of the circle, which is circle H. So I'm going to do HW, then I see HT, and I see HS. So that's 3 radii. The tangent that I see here, again, which is got that point of tangency, which is point Y. The tangent is that line YP. Right, so that's the tangent line. A diameter has to go through the center, so through H, I see WS is my diameter. And then draw secant AB, so I'll go ahead and draw the 2 points. So there's A, there's B, and I'm going to draw the line that goes through those. All right, so there is secant AB. Okay, so now let's answer these 4 questions based on some of this vocab. A diameter is a chord. So a diameter is a chord. Okay, so diameters, they're going to go through the center of the circle. If we go back up here, right? A chord is a segment whose endpoints are on the circle, and a diameter has to go through the center of the circle. And you notice in the definition, the very first thing that it says is it is a chord. So when it says a diameter is a chord, this is always true. A segment with both endpoints on a circle is a radius. So both endpoints on a circle, that's actually a chord. Radius has to have one endpoint is the center of the circle, so this is never true. A secant to a circle is a tangent to the same circle. We drew secant AB, and secant has 2 points. All right, it's a line that goes through 2 points on the circle, and you should know from looking at our tangent YP, or in the definition, a tangent is going to intersect the circle at 1 point of tangency. This is never going to be true, right? If it is a secant, it's going to have intersect at 2 points, and a tangent is going to intersect at 1 point. And a chord of a circle can be a radius. Let's see, a chord has endpoints that are on the circle, and does not say in terms of a chord that you have an endpoint that is the center. So no, this is never going to be true. Okay, so let's look at some 2 theorems here that we're going to use on a few questions in a moment. So the first one is called the tangent line to circle theorem. So this says that a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. So again, unless you're told it's a tangent, you would have to prove this first before you can use the fact that you have that 90-degree angle. All right, there will be instructions later on these problems that say if it looks like it's a tangent, go ahead and assume it is. But if it doesn't say that, you do have to make sure that it is perpendicular before you can use that right angle. Okay? All right, the next one is the external tangent congruence theorem. This says segments that are tangent to a circle and have a common external point are congruent. So we can assume that if they tell us that AC and BC are tangents, and they tell us that, or they have that same point C, then we're going to assume that those segments are congruent to each other. Okay, so let's do 5 questions together. I'm not going to do all of them on here, but you can check out the key on Canvas for the ones that I don't do. So I'm going to do 1 through 5, essentially. So number 1, determine if segment PQ is tangent to circle R. So I see PQ is right here. If this is going to be tangent to circle R, then that means that this right here is going to need to be a right angle, which means that this triangle created, PQR, needs to be true in terms of Pythagorean theorem. So if I plug this in, this better be a true statement. So I see 10 is a leg, I see 16 is a leg, and then the hypotenuse is going to be 20 squared. Oops, my bad. All right, you'll notice here that this segment here, the small segment, I'll highlight it. This is 10 here, and because 10 is PR, this is also a radius of 10, so that's going to be 20. So I have 100 plus, I believe that's 256 equals 400, and that's going to be 356 equal to 400, which is not true, right? That is not true. So if that does not make a true statement, then segment PQ is not tangent to circle R. Okay, let's do the same thing with number 2. Determine if JK, right, so JK is tangent to circle L. So I'll make that right angle again here. All right, so let's set up our Pythagorean theorem to see if this is going to be a true statement. All right, I notice that this is also 4.2. Okay, so let's see, one of the legs is going to be 2 radii, or the diameter of 8.4. So square that, plus 8 squared equals 11.6 squared. I do have some decimals here, so I'm going to use my calculator. So 8.4 squared, that's going to be 70.56. I do know this is 64. And then 11.6 squared. 11.6 squared is 134.56. Oops, same thing. Okay, so 134.56. I want to add those together. Let's see, 70 and 64. That is 134, and then add the decimal point 56. That is true. So because those are equal, then I'm going to say that JK, that segment, is tangent to circle L. All right, so that's how we're going to do the math to prove whether these segments are tangent or not. Okay? Okay, so I mentioned this a few minutes ago, but here it is. It says, for the following problems, assume lines that appear to be tangent are tangent, and then if necessary, give an exact answer and round to the nearest tenth. So again, it doesn't say that this, I'll highlight it here, that this is going to be tangent, but because it looks tangent, and I have that instruction, I'm going to assume it is tangent, and so it creates that right angle with this intersection, this point of tangency with the fact that it's a radius, so create that right angle, or my right triangle. So to find this x, which is the hypotenuse, I'm going to use the Pythagorean theorem again, and I'm going to use 9 squared plus 19 squared equals the hypotenuse of x squared. All right, so that's 81, 19, I think that's 361. So adding those together, 361 and 81 is 442. But again, that's x squared. So to get x by itself, I'm going to take the square root of 442. Oops, sorry. The square root of 442, which to the nearest tenth is 21.0 units. So approximately 21, I think I wrote the wrong number, 21, I was right, 21.0 units. All right, that is x there. All right, the exact answer would be x equals the square root of 442. And if you want to break that down, you could. Okay, let's do number 4. All right, it says solve for x. Again, like we just had, this looks like it's tangent. So I'm going to assume it is to make that right angle. All right, this right here, 10.2 is a radius. So this is also 10.2. So to set up my Pythagorean theorem, I'm going to have 10.2 squared. All right, that's one of my legs. Plus, I don't know that leg, x squared, equals, if I add those together, I get 17 squared. So 10.2 squared, that's going to be 104.04 plus my unknown squared. This is 289, I believe. I'll confirm. Yes, 289. Subtract the 289 minus the 104.4. Excuse me, 0.04. 184.96. So x is going to be the square root of that, which is 13.6. So 13.6 units for that leg. All right, last one, and then we'll be finished. Number 5. All right, it says find x, y. All right, so x, y is one of the radii here, or a radius. So I'm going to use the fact that this yz looks to be tangent, so it is tangent, which creates that right triangle. So I have enough information to find this right here, which would be the one of the legs of the right triangle. But you'll notice it doesn't say wy, right? That's actually the diameter. It says xy, so once I get wy, I'll need to cut it in half to find the radius xy. So using Pythagorean theorem again, I'm going to write 13.8 squared plus, and I'm just going to go ahead and put wy squared. Again, this is going to be my diameter, equals 23 squared. All right, so 13.8 squared. Oops, I missed one there. 13.8 squared is 190.44 plus wy squared equals, I don't know 23 squared off the top of my head, which is 529. Subtracting that 190.44 to the other side gives us 338.56. All right, I do not want that squared. I want it to just be wy, which is my diameter. So I'll take the square root of that, which is 18.4. But again, that's not my answer, right? That's the whole side there, that whole leg, that whole diameter. So to find xy, I need to do 18.4 divided by 2 to get the radius, which is 9.2 units. All right, that's it for this video. Check out the other questions, check out the homework, and come see us if you have any questions. Good luck.